Okay, so this is part 2 of the history of periodontium. Okay. Okay. So we stopped at cementum repair. So again, this involves layering of the cementum when it follows resorption, traumatic resorption, such as occlusion, orthodontics, exfoliation, or eruption. And again, we have arrest lines that reflect modeling. Like think about like if you were to get like a skin graft or something, you will see where that new skin overlaps the other one. And that's kind of what this looks like. It's kind of like a piece of a puzzle as well. So those are arrest lines. Cementicles, these are spherical calcified bodies. These can be embedded in the cementum or they could be free in the PDL, and they're usually seen because of the layering of the cementum around debris. It degenerates remnants of the epithelial root sheath, and it's trauma to it comes from trauma to the Sharpie's fibers. Cemental spurs, these are spheres of cementum attached to the root surface at or near the CEJ. It results from irregular deposition of cementum. It is similar to enamel pearls and is not easily removed. Hypercementosis, we learned about this in radiology. This is when too much cementum is being formed. It's found in the apical region and it can be localized or generalized. So look how big these roots are. Hypercementosis usually comes from trauma from occlusion, chronic inflammation, loss of an antagonist tooth. So if you were to lose the mandibular tooth that where we interdigitate, if you lose that one tooth, that can lead to hypercementosis, and it's usually a response to attrition. There are two types of cementum. We have acellular and cellular. Acellular or primary is the first layer that happens before eruption. It goes at a very slow rate. It stays a constant width over time, and one layer covers that entire root. Many layers cover the cervical 1/3 to the 2/3, and it's about 0.1 millimeters thick. It has less organic matrix and it's better calcified. For cellular cementum or secondary cementum, this is the last layer. It goes over the primary or acellular. It happens after eruption. Its apical portion in interradicular areas is 0.5 millimeters thick, and it goes at a very fast rate. It has peripheral cementoblasts, it has lifelong deposition, and it has arrest lines. It produces arrest lines, and it's similar to the bone tissue. Now we're going to go over alveolar bone. So this is part of the maxilla and the mandible. Its existence or presence is dependent on the presence of roots. It does not develop if there aren't any teeth, and it resorbs after extractions. Alveolar bone has the same biophysical and chemical properties as other bones, so it's the same thing. The crystalline portion is calcium hydroxyapatite. The alveolar bone is 60% mineralized, 25% organic, and 15% water. The organic material, just like before, ground substance is proteoglycans, primary collagen is the fibrous matrix. The inorganic component is calcium and phosphate salts. It provides rigidity and allows bones to withstand compression. There are three major cell types. You have osteoblasts, osteocytes, and osteoclasts. You should know what all this stuff is. Osteoblast is the immature that secretes the osteoid. Osteocytes is when the osteoblasts become embedded in the lacunae. Remember, they get stuck and then they mature, so that's osteocytes. And then osteoclasts, that destroys and resorbs the bone. Clast means resorb. There are two types of bone. You have alveolar bone and basal bone. Basal bone is apical to the roots. It forms the body of the maxilla or the mandible. The alveolar bone, or the alveolar process or alveolar ridge, this contains roots. It's divided into alveolar bone proper and supporting bone. So the alveolar bone proper is the numerous small openings that allows blood vessels and nerves of the PDL to communicate. Alveolar crest, which we know what that is, it's the most cervical part of the alveolar bone proper right over here. And then here's the alveolar crest on a radiograph. Lamina dura, remember that's the radiopaque line that surrounds the tooth. And then the PDL is that radiolucent line because it's a space. Space has more density. So supporting alveolar bone, that consists of cortical bone and trabecular bone. Cortical bone is compact bone on the facial and lingual. Trabecular bone is cancellous bone between the cortical plates. Supporting bone has two septums. It has an interdental septum and an interradicular septum. It's exactly what you think. So here's the interdental in between two teeth. Interradicular is right in between that crotch area. And then alveolar bone goes under constant remodeling, periods of formation and resorption, depends on functional demand. It's easily remodeled compared to cementum, and it goes through orthodontic movement. So when you get braces, your teeth are moving. So where the pressure is going towards, you have compression. So it's compressing that area. So right here, the pressure is going this way. This way, you see how these lines are very squiggly. That's because it's being compressed. That's bone resorption. Where the tooth is moving from is the tension zone, where you see bone deposition. Look how straight and tense these lines are compared to these squiggly lines. So this is review, development of the maxilla and the mandible. It develops in the first branchial arch. It happens in small centers of the intramembranous ossifications around the mouth, and that is it.